Hello everyone, today I want to explain my homework file, homework 2 exercise 5.3. Write a HTML, CSS, and JavaScript to control temperature via mobile phone. Next are the four core objectives of the project, which also serve as the core guidelines throughout our entire development process. Achieve stable connection between ESP32 and the Wi-Fi network, which is the basic premise for remote control. Be able to automatically control the switching of LED light according to the percent temperature to simulate cooling and heating effects. Enable the system to have automatic response capability. Clear function indication. The blue LED represents the cooling system and the red LED represents the heating system. The working status is distinguished through intuitive light colors. On the main interface of the mobile phone or web terminal, support user to customize the indoor target temperature to meet personalized control needs. These four objectives runs through the entire process of the project and are also the core basis for our subsequent design and development. To complete this homework, I used the key tools or directly related to the implementation. Visual Studio Code, the main editor for writing HTML, CSS, JavaScript, and No.2's C++ code. It supports highlighting and real-time previews, which is essential for code development, and Output I/O, the IoT platform that acts as a bridge between the mobile interface and the Node MCU. It forwards commands from the front end to the hardware. Enable data communication and fear-based, used to deploy the front-end code online. Without it, the mobile interface would only run locally and the remote control wouldn't be possible. The hardware needed is straightforward and all is necessary for the physical control part. Hardware is the foundation for the project to be implemented. When selecting hardware, we focus on complete stability and cost effective. And finally, determined the following core hardware list. ESP32 development board as the core of the system. It has a Wi-Fi communication function, supports wireless communication with the cloud and the mobile phone terminals, and has rich GPIO interface which facilitates the connection of sensors and actuators. DHT11 temperature and humidity sensor. This sensor is a high-cost performance and strongest stability and can accurately collect environment, temperature, and humidity data, meeting the basic data collection needs of the project. White LED light is used to simulate the working state of the refrigeration system when the system starts the refrigerate mode. The blue LED light turn on. Green LED light HS used to simulate the working state of the heating system. When the heating mode is activated, the green LED turn on. Dupont wire and data cables used of circuit communication between hardware to ensure stable single transmitter and the breadboard. In terms of hardware connection, we adopt a simple and reliable wiring method. The GPIO interface of the ESP32 is connected to the data pin of the DHT11 sensor. The control pins of the white LED and the green LED respectively through Dupont wires. At the same time, ensure that the power and the ground pins are connected correctly to avoid short circuits or poor contact. What is displayed on your screen is a physical connection diagram, which clearly marks the connection relationship between the key pins of the ESP32 development board, such as both 3 white, 3 ground, and other hardware. Following this diagram, you can complete the hardware assembly, laying the foundation for subsequent software debugging. No.2 configuration is mandatory for communication, and every step is tailored to the homework code. First, log into out.io and create a single device named SW52. This name must be integral to the one in the C++ and JavaScript code. Customization, so no tabs are allowed. Create a console named test with the tab set to integer. This symbol is used to transmit control commands, 1 for on, 0 for off, and the integer tab ensures the node MCU can parse the data correctly. Generate a key and copy it. This key is used for other location in the code, ensuring only our homework project can access the device and cancel. Increase configuration here will result in failed communication between the front end and the hardware, so it's a critical step in the homework. Which is the core of the project C++ code. We will explain it to you in 3 modules. First, let's look at the first module, the function and the key implementation of the ESP32 core code. The code goal of this part of the code is realize the 3 module functions of connection, communication, data forwarding, which especially include connecting to the Wi-Fi network by configuring the SSID and the password of Wi-Fi. The ESP32 automatically searching for and connects to the specific network after startup, providing a network foundation for subsequent cloud communication. Connecting to the NetPin cloud platform. NetPin is a cloud platform specially designed for IoT device, supporting device access, data transmission, and command initiation. We realize the stable connection between ESP32 and the cloud by configuring the client ID, Tanko, and the APP ID, subscripting to and publishing topic. We define the control command topic, CMD topic, and the status feedback topic. The ESP32 receives commands from the mobile terminal or web terminal by subscribing to the control command topic, and upload the temperature and humidity and device working status to the cloud by publishing the status topic. Sexual communication. The ESP32 interacts with the sensor and actors through the several ports, reads the temperature and humidity data from the DHE11 and forward control commands to the LED enter at the same time. Next, let's look at key codes segments. In the setup function, we first interline several communication, then start the Wi-Fi connection. Judge the Wi-Fi connection stands through a loop and print the local IP address after a successful connection. Then interline the NET PIE connection, subscribe to the control command topic, and specify the callback function on command received. After receiving the command, in the loop function, the circle operation of NET-PIE is mainlaid, and several port data is entered at the same time. When temperature and humidity data upload by the sensor is received, it is published to the stands topic through NetPin. The callback function on CMD received is responsible for receiving control commands forwarded by the cloud and forwarding them to the accounter through the several ports, so as to realize the switch control of the LED light. It should be noted here that the Wi-Fi information SSID and password in the code and the device information client ID, token, application ID of the NetPin platform need to be replaced with the actual configuration used to ensure a successful. Let's continue to introduce the code logical of the second module in software design. Sensors and actors. This part of the code mainly runs on the ESP32, and its code function is to realize the closed loop of instruction, encryption, data collection, data upload. Specifically, the curl function of the code in cloud. Receiving control instruction from the ESP32 code models through the several ports such as target temperature, cooling or heating mode, switching instruction, controlling sensor collection, frequency, adjusting the collect interval of the DHT11 sensor according to the received instruction. For example, when the temperature fluttered greatly, increasing the collect frequency to ensure that real-time performance when the temperature is stable, reduce the collection frequency to save power consumption, collecting temperature and humidity data, driving the DHT11 sensor to collect environmental temperature and humidity data, and performing data verification to ensure data accuracy. Uploading data to the ESP32 Crow model, setting the verified temperature and humidity data to the ESP32 Crow model through the several ports, and then the Crow model uploads it to the cloud. The K-code models are mainly divided into two parts. One is the several communication model, which is responsible for data exchange with the ESP32 Crow model, including instruction reception and data transmission. It monitors several port data through several available and read communicate instruction and data use several read threading until the other is the sensor data collection model, which intelligences the sensor and codes the reading function to operation data through the DHT11 driving library, and at the same time had abnormal situation where sensor reading fails to ensure the stable operation of the stem. This part of code is a bridge connecting the hardware and the control logic, ensure that instruction can be accurately translated and data can be really collected. This page is divided into four modules: target temperature, display area temperature and humidity cards, control boards, and static interactors. Pass the Crow structure symbol below. Web scope API on open or on message or on close Crow life circle events for real-life byte created real-time communication. Disconnection reconnection measure same set timeout into WS5000 ensure communication stability, a universal solution for Internet of Things IoT frontiers. Data boundary processing max 0 byte max mean 100 or something limits the progress bar percentage to 0 to 100% to avoid UI exception. To fixed 1. Formats floating point number to ensure in-field temperature display process. Deployment is the final step to realize remote control, a required part of the homework. Install Firebase tool via npm install gfirebase tool tools like one the login to Firebase. Negative to the project folder and run Firebase into select hosting and set the public directory to public. Choose no when asked to overwrite index.html to preserve the homework's code. Run Firebase deploy line 1 to upload the front end code. The deployed URL allows any mobile phone to access the interface. Alignment is mandatory because the homework requires remote control. Local code can't achieve this. Now let's look at this video. This is all my homework 5.2. Thanks for listening.